So in order for it to be approximately normal for us to meet the conditions, all three of these things have to be true. Okay, so let's look at an example because this is new. If you understand how to do the first one, what I want you to do is after we read the problem together, pause it and see if you can figure it out. And if you can't, just push play and we'll answer it. So let's go ahead and read it together. We have many new products introduced into the market are targeted towards children. That's true. The choice behavior of children with regard to new product is of particular interest to companies that design the market strategies for these products. So if the companies are advertising, they want to make sure that it's working, which makes sense. As part of one study, randomly selected children in different age groups were compared on their ability to sort new products into the correct product category, either milk or juice. Researchers want to know if a greater proportion of 6 to 7-year-olds than 4 to 5-year-olds can sort correctly. State the appropriate hypothesis for performing a significance test and be sure to define your parameters of interest. And then it says here's some of the data. Boom, magic. In case you're wondering, I paused the video to go get the data, but I forgot to put in anyway. Okay, so let's go ahead and start with what we need to know. So one way that I like to start these is I like to go ahead and define what my parameters are going to be. So I'm going to say that let's go ahead and define the parameters. We're going to do P sub 1 first. Let's say that that is equal to the true proportion. So going off of the sample, remember a sample statistic estimates a population parameter. So this is going to be the true proportion of 4 to 5-year-olds that can sort correctly. Oh, okay, going off a little bit correctly. Okay. Now the reason why I'm identifying the top one as P sub 1 and the bottom one as P sub 2 is because that's how it was introduced in the data. That's what they had first, so I'm putting it first. The next thing that we need to do is we need to define what is P sub 2. P sub 2 is going to be the exact same thing, but instead of 4 to 5-year-olds right here, it's going to say 6 to 7-year-olds. Ta-da! Copy and paste. Works great. Okay, so let's go ahead and write out our null hypothesis. So that's the next step, because that's what we're doing. So the null hypothesis in this case, H sub O, remember, it's always going to be the exact same thing. So we're going to have P sub 1 minus P sub 2 equals 0. We are saying that there is absolutely no difference between 4 to 5-year-olds and 6 to 7-year-olds. That's just the beginning thing. That is the original claim that there's no difference. They're equally likely to sort their milk and their juice. So the alternative hypothesis, H sub A, we're saying that the difference, so that's going to be the same also. We're saying that the difference is actually going to be that if a greater proportion of 6 to 7-year-olds, so they want to say that these guys, P sub 2, they're saying that these are better. So because they're saying that those guys are better, that means that this number should be a bigger number and this number should be the small. So if you subtract a small number minus a big number, you get a negative, which means that this is going to be less than 0. So it's kind of confusing just because of the lingo and the way that it works. But they're saying that the sample proportion of 6 to 7-year-olds is going to be greater, which means that if you subtract the proportion of 4 to 5-year-olds, from the proportion of 6 to 7, it's going to be a number, it's going to be a negative number that's less than 0. So that's that part. Let's go ahead and check some conditions. So let's do conditions. Okay. So the first question is it random? So if you look in here, it says randomly selected. So yeah, it is random. The second question is n times 1, is n1 times p sub 1 greater than or equal to 10? So, well, let's figure out what these things are. We probably should have done it in this stage. So n sub 1, the sample size for the 4 to 5-year-olds, is 50. That sample proportion is going to be equal to 10 over 50. N sub 2, the sample size for the second set of data, is 53. And the sample size for the second group is 28 over 53. So we have that information. So now we're just going to plug it in. So 50 times 10 over 50. You can put this, if you want to put it as a decimal, you can, 1/5, which equals 0.2. That's fine. Is that greater than or equal to 10? So 10 is greater than or equal to 10, so that's good. So let's check out the next one. N times 1 times 1 minus p sub 1. Notice that I didn't write the number 3 because this is still classifying, or this is still classified as the same conditions check. So now we're going to do 50, the sample size, times 1 minus 10 over 50, which has to be greater than or equal to 10. I told you guys once before that these two numbers should add up to get your sample size. So 50 minus 10 is 40. If you don't believe me, put that in your calculator. DesmosScientificCalculator.com. But both are greater than or equal to 10, so condition number 2 works. Okay, so let's look at condition number 3. So is n times 2 times p2, sorry, not n times 2, n sub 2 times p sub 2, is that greater than or equal to 10? So our sample size for the second set of data is 53 times 28 over 53. Is that greater than or equal to 10? Boom, 28 is greater than or equal to 10, so that's good. And check the last one, n sub 2 times 1 minus p sub 2 greater than or equal to 10. So we're going to have 53 times 1 minus 28 over 53 greater than or equal to 10, and you get 25. And 25 is greater than or equal to 10, which means that this is approximately normal. By LCC, and remember LCC stands for large counts condition. Ooh, this is a long video. Sorry guys. If you want to take a break, go ahead and take a break for a second. Alright, just kidding. We're gonna move on. The second example. So let's go ahead and check it out. So we have the difference of the sample proportion says that it's going to be none. The sample, or the alternative, what we're trying to test is that 4 to 5-year-olds aren't as great as the 6 to 7-year-olds, and our conditions are good. What's going to be happening next week and the following week is we're actually going to be testing to see, we're going to get the answer in later weeks. So right now, all we're doing is figuring out, hey, what is the hypothesis and are the conditions good? So this is all we're doing for this week. We're pretty much just doing state and plan. So we'll do the do section and the conclude section next week. Actually, no, next week we're doing confidence intervals. Never mind. Anyway, next example. So this one is about opinions, I guess. It's pretty interesting. Does the order in which options are presented influence people's